Under this third method, using a sampling distribution, we have two methods that we're going to learn, and they're both very important. Confidence interval, critical value. Let's start with the confidence interval. So starting here from this distribution, right? So we have our sample, our main number in the sample, and the number is 1. Okay, so we have that number there. Okay, cool. So the number 1, let's derive it. Let's derive it to sampling distribution. Let's turn it into a range. So we're going to plug in this number 1 there, and we're going to expand it to find the 95% confidence interval, right? The lower bound and the upper bound. Now, does this range include 0? That's the question that we're trying to answer. Does this 95% range include 0? Well, in order to answer that, in order to find the range first, we need to understand two things, which we discussed before. Remember, the standard deviation is the word we use for a distribution of the sample, for sample distribution, okay? Whereas the standard error is the distribution that we use for a sampling distribution. This is a sampling distribution, and this is a reminder. And again, if you're watching this and you don't understand what sampling distribution really is, or you think that like I'm talking about a sample, you don't really understand, like, man, rewatch the class. It's very important to understand that. Otherwise, nothing's going to make sense, okay? So, all distributions class. So, a standard error here, right? So, we have the standard error. This is going to be sort of the distance between the average and the first z-score bar, right? So you're going to get the standard error from your SPSS output. You don't, like, it comes to you, right? So it's given to you. You don't have to learn how to calculate it. They're just going to give it to you. Hey, this is the standard error. The standard error that we're given here is 0.6. So we can just plug it in here. The standard error here is 0.6, which means that, you know, if this is a 95% confidence interval, the bounds are going to be at 1.96 plus and minus z-scores. Okay, so plus 196 minus 196, which we can find at the z-score table that we learned also in the z-score class. Now, the z-score here is plus 1.96. So the distance between the average and the point 1.96 is going to be 1.96 times the standard error. Okay, so we just plug in 1.96 because that's the z-score of the cut point, and we plug in the standard error, and we multiply that we're getting from the SPSS output, and we plug it in there. We multiplied 1.176, okay? So the upper limit is 1 plus 1.176. The upper limit is 2.176. And we can do the same thing for the lower limit. We know the distance is that, so we can just mirror it because it's perfectly symmetrical. And we can subtract, so it's minus 0.176. And at this point, we can get rid of the 1, you know, because fuck the 1. We don't give a shit about the 1. The point is minus 0.176 to plus 2.176. This is the 95% range, right? If you remember how to interpret this, this is saying that we're 95% confident that the main number in the population is between minus 0.176 and 2.176. How do we know that? Well, because we know that if we were to draw 100 samples from the population, 95 of those samples would have values between negative 0.176, 2.176, okay? That's just the clarity.